My name is Betsy Zakakis. I'm Vice President of Marketing at RightScale. I'll be your MC for today. So joining me today, right next to me in fact, is Michael Crandell. He's one of the founders of RightScale and our CEO. He'll be doing most of the talking. We also have David Welch, a sales engineer, who will be demonstrating how to build scalable websites in the cloud using the RightScale platform. Online, we have Hunter Williams and Daniel Howard. They are ready to answer your questions. So if you have a question, don't wait till the end. Go ahead and enter it into the chat window on, I think, the bottom right of your screen. And we'll answer them as we go through the webinar. And then we're also going to open it up at the end with a live Q&A where we will repeat some of the questions that are interesting, some of the ones that have been asked over and over again. So we have one logistical item. We understand from our friends at Citrix Online that if you're listening to the webinar using a VoIP connection, your cell phone, there's a potential for your cell phone to interact with it. So if you're hearing any kind of crackling, find your cell phone, turn it off, and it might fix the problem. So with that, any other logistics we need to take care of? Okay, so I'll turn it over to Michael.
Good. Thank you, Betsy. Let's dive right in. Quick overview of what we'll be covering today. We're going to do a brief intro for those who are new to RightScale of what RightScale is about very quickly. Also cover why cloud computing is important today, again, very briefly for those who are new to the subject. And then dive into to show you a live demonstration as well as a quick overview of some websites that have actually been implemented and a quick case study overview of those. And then as Betsy mentioned, we'll have time for questions at the end, but we do have two gentlemen online right now ready to answer your questions, and we don't want them bored, so please fire away as we go. So just as a quick introduction, RightScale, really the hallmark of RightScale when I think of it is the way we've engaged with customers and actual users of the cloud from the very beginning. RightScale launched as a free website. Today we have nearly 15,000 users who've signed up to use the free website. We have many hundreds of paying customers. We've launched nearly 500,000 servers and powered some of the biggest scalability events that have occurred in the cloud to date. And we'll talk a little bit more about those later. But the point is, I think, that we have a very good viewpoint from our perch as to actual production usage of the cloud today. So a quick mapping for those who hear the term cloud computing all over the place, all over the press. Really everyone is calling themselves a cloud or a cloud application today. Really what's become standard is dividing the cloud models into three areas. One is, of course, software in the cloud or software as a service. There are platforms in the cloud. Example of the first, Salesforce.com. Example of the second, Google App Engine, or what Microsoft Azure will probably become. RightScale fits on top of infrastructure as a service. So infrastructure in the cloud, these are providers like Amazon, GoGrid, FlexiScale, as well as private clouds like Eucalyptus and VMware. And RightScale lives on top of these low-level cloud infrastructure resources, helping you to automate them, manage them, and really leverage them very quickly to run your applications. And we do that in an open way. So you can see in this slide the dotted lines on the side representing that you have freedom to choose operating system, data model or database, programming environment, etc.
Okay, at this point, I think we're going to try to launch a poll and see what's driving our audience to the cloud. So here are some options. If you don't find the reason that you're looking at cloud computing to build a scalable website on here, select other, and then in the chat window, give us an idea of what is driving you to the cloud. For the people who don't understand what some of these are, scalability is the ability to scale up when needed and then scale down the resources when they're not needed anymore. On-demand access is the ability to access virtually unlimited amounts of resources when you need them, providing a large amount of agility for your business. Cost savings is just that, savings accrued by deploying on the cloud instead of in a more traditional, either a hosting environment or in your data center. And backup and recovery, some of our customers are using the cloud to stage and execute, if necessary, backup and recovery strategies. So how are we doing? Looks like we've got enough. Let's show the results. Lots of scalability, lots of cost savings. I think very typical of what we see from our customers.
That's right. That's what we see a lot, as well as, over half the people are interested in the business agility on-demand access version also. Great. So just moving ahead, to that point about scalability, here's a simple diagram kind of showing how that has been handled in the past and why, classically speaking, it's been a problem in IT infrastructure. And it's because, as you can see from this diagram, the red line represents actual demand. That demand might be for a production website. It might be for a staging or development system when part of your organization says, hey, we'd like to throw up another development system for testing. But basically, the demand for IT infrastructure resources fluctuates over time in almost every case. And traditionally, when you build out your own hardware or lease hardware on a long-term basis from a traditional managed hosting facility, you're faced with really going in stair-stepped acquisition model. And that's the blue line there of having a certain amount of hardware. It's fixed. Then you acquire some more. And you go in that stair-step fashion. The problem with this model is that there's either an opportunity cost where you've bought more infrastructure than you need, as represented by the green arrow, or you get caught in a perhaps worse situation, which is you didn't build out fast enough, and so the demand exceeds what your infrastructure can handle, and you get slow websites or non-responsive crashed websites, etc. And that's where you lost customers, whether those customers are through a public website or whether they're internal users who are frustrated because you can't meet their needs. So that's the classic problem, and clearly it's solved in the cloud. It's solved with managed cloud resources, and what you can see here is the yellow line represents infrastructure that's automatically launched in keeping with demand. And I'd like to turn for a second to David Welch. Would you just give us a little peek of what that looks like initially, how that works inside RightScale?
Sure, no problem. Thanks, Michael. So I want to preface this by saying that RightScale is a rules-based engine, and what you're looking at here are the monitoring graphs for one of our front-end servers within a deployment. Now, monitoring lays the foundation for all automation and auto-scaling that takes place in the cloud. So let's go ahead and take a look at some real-time load on this front-end server. As the load starts to increase, once it reaches a certain threshold, in this case I believe it's 55% for 3 minutes, it'll auto-scale the servers up. And that's indicative of this spike up and reduce load. Now, just as important as auto-scaling up, you also want to auto-scale down in order to save cost. So what you do is you set another alert to monitor when it reaches a certain threshold to deprovision servers when necessary.
So let me just ask a question here, just so we're clear. This top graph here says CPU idle time. So is that actually backwards, or what does it mean? Normally when something's dropping, it's getting less busy. Is this reversed?
Yeah, so this is the CPU idle time. So as it starts to go down, that means there's more load on the server. And when it's higher up, that means it's idle.
Okay.
Now I want to talk about or touch upon this spike up and reduce load. So here at RightScale, we believe that the most difficult part of auto-scaling isn't the actual launching of servers, but it's the lining up of all the configuration and lifecycle management so the new servers go into production successfully, and that the dynamic runtime self-configuration is where RightScale really shines. So now I'm going to hand it over to Michael, who will touch upon those points in a little bit more detail.
Sure. Before we do that, could you just, let's go back to your graph one more time and expand the yellow and blue, or sorry, the green and blue one there. To a now format so we can see it expanded. So that's really the same diagram where green is idle time or free time and blue is busy time?
That's right. So we just provide a breakdown of what's taking up the most load on the CPU.
So one way to think of that is the same sine wave you see at the bottom of the actual website requests would have been represented in the blue curve, except that additional servers were launched to free it up.
Exactly.
Yeah, good. Okay, thanks. So you've just seen, a very quick view of the beginnings of how autoscaling works, really stemming from monitoring, low-level monitoring that's keeping track of how busy your servers are, and then which is the seed for launching more servers. We'll talk a lot more about that later. But here's more of a broader picture of RightScale and its place in the puzzle. We really live between the area of the low-level infrastructure clouds at the bottom in orange and red, and then applications that companies want to deploy in the cloud, in this case, a scalable website. And we deliver value really through three ways. One is the automation architecture, which we'll, as I said, talk more about. The second is providing cloud-ready solutions for very common componentry. So, for example, a scalable MySQL database that's got failover built in, scalable web front ends, a grid framework, etc. Those are cloud-ready solutions that we provide, both from ourselves as well as from partner companies. And then finally, RightScale backs all this up with expertise from our services department, which really is there to help companies get implemented on the cloud by providing an onboarding consulting capability as well as ongoing support. So let's take a look at some of the actual case studies that we have accumulated from different types of usage in scalable websites.
Yeah, Michael, these are some of our customers, some of the logos from our customers that are actually deploying scalable websites on our cloud or on the cloud using the RightScale platform. And what we find is that they can be categorized into at least 4 here that we've listed different types of websites. So we thought as we talk about some of these different types and their demand patterns that we would again do a poll, our last poll, and find out where you guys fit in the audience. Again, if you don't feel like these represent what you're trying to deploy on the cloud, then select other and let us know through the chat window what what you are trying to do. But as you give the answers, let's just kind of go through and I can talk about some of these. The Web 2.0 sites like Share This, iFixit, Foreclosure Radar are customer-facing sites, and their spikes often are as a result of successful PR, successful marketing campaigns. We've had some of our customers be featured on Oprah or 60 Minutes with very little notice, not enough notice to actually build out the infrastructure required to deal with that kind of demand. We've had others that show up on Dig and are promoted to the front page and get tremendous spikes, success spikes.
That's right. That's right. And these are sites, a Web 2.0 site typically has, of course, the web and application server front end, but also almost all of them are database backed. So there's a database component there also.
Yes, yes. The social game providers like Playfish have a little different pattern. They have millions and millions of consumers coming to their site, many times geographically dispersed consumers coming at different times of the day to interact with the site, to interact with each other. And what it creates is very unpredictable demand. They have huge spikes sometimes, and then some other times they don't. So they really need to deal with this.
Absolutely true. Very highly interactive graphical sites normally. And often companies like that take advantage of additional content distribution network services, CDN services, to help with that global load that they experience.
Yes, yes. Now, mobile services, StarCut is one of our customers, and they're creating mobile services and portals for their customers, and they often have predictable demand. They're delivering information to consumers that sometimes come at the same time of the day. So, you think about what you do. You go in the morning to look at your news. You go at the end of the day to check the stock quotes. And so they can actually predict the demand and scale ahead of time.
Exactly right. And we'll talk more about them. In fact, I have some slides later to show exactly those loads that they experience.
Yeah, some really interesting slides. And finally, the media processing sites, they're very different. Because media processing is inherently compute intensive, they benefit by not only scaling the front end, but also scaling the back end. And by scaling the back end, they can dramatically reduce the wait times for their customers. And I think we'll see that toward the end too. We'll see in architecture.
We will. We will. So why don't we go ahead and wrap up the poll and get back to our webinar view and see, are we going to be able to see what the results are there?
Oh, yeah. Okay.
Okay, so it's a majority Web 2.0 applications, and then, interesting, second place is mobile services. And actually, second place is other.
Okay.
So if you folks have input about what other means, please go ahead and fire away on the chat window. We'd love to hear what those applications are, and maybe we can address those more specifically as we go on. So Betsy, you mentioned in terms of mobile applications that's one whole category. And in fact, here's an example from our customer StarCut. They are a company that actually powers mobile delivery of content on PDAs, mobile phones, etc. And this is an example, and really the reason we show this is the RightScale monitoring graph at the bottom really represents the kind of load they experience when they publish stock quotes. And you can see I call it kind of a devil's horn pattern, but you can see that people get up in the morning, check stock quotes in the morning, it tapers off a bit at lunch, they check them again late afternoon, and then it goes away in the evening and on the weekends. So this is a very predictable kind of variant load that they actually solve through a kind of scaling that RightScale offers called scheduled scaling. It's done automatically, but obviously Monday through Friday they can predictably launch servers to make sure that they're running long before the load hits. Another example from StarCut is their powering of CNBC's coverage of the Beijing Olympics last summer. And you can see just after week 33 there, the biggest spike, that was actually historically when Michael Phelps won his record-breaking 8th gold medal during the Olympics, and so there was a big spike, word got out, and people were checking that news on their mobile devices. But if you talk to the system administration staff at StarCut, what they'll tell you is, as great as that was, what was really important to them was over to the left of week 32, where you'll see an even higher spike. And what's critical about that is that was when StarCut was able to load test the system and validate it long before the Olympics ever started. So another ideal application, and it points to the cloud as an ideal place, not just for production systems, but for test and development also. Another example, one of our favorite companies is a company called Animoto.com. Some of you may have heard this story. If you don't know Animoto.com, I suggest you go check it out. They actually have the capability of a free trial. Animoto takes still digital photos that you upload and combines them with music that you choose to create really compelling movies, animated versions of your images in time and in keeping with the mood of the music. And so as you might imagine, this is not just a Web 2.0 site, but it's very processing intensive. And in fact, last year when they launched a Facebook version, they ended up scaling from 50 servers to over 3,500 servers in 3.5 days. And this is the graph that shows what actually happened last April when they did this. It's a testimony not just to the incredible infrastructure resources available in the cloud, but to the automation that's required throughout that process of bringing servers on automatically. And then you can see at the end, as the promotion ended and the demand slacked away, also decommissioning servers. One more example of extremely spiky traffic is with our customer iFixit. They power a site that shows how to tear down equipment. That's up to you if you want to take apart your iPhone or MacBook and replace the battery or the CPU or whatever. So it's been a very popular site, and obviously they get traffic around new announcements of products. And so you'll see on their blog that performance on their website is very important to them, and that thanks to cloud computing and Amazon EC2 and RightScale, by the way, they can dynamically scale their capacity to meet demand. So those are just a few examples of many, many websites, production websites that take advantage of scalability in the cloud. And before we dive into the actual demo, I just wanted to walk through really how complex the real requirements are, because on the surface it seems that it's easy to detect that a server is busy and just launch a new one, but it's actually more complex than that. So it begins with that detection, with monitoring and alerts and escalations in our system, and David will show you more about that in a minute. But once you detect that a server needs to be launched, auto-scaling is actually quite a bit more than just auto-launching of servers. And it's quite a bit more because you really have to take care and allow for the dynamic configuration of servers as they launch. And that means as they're becoming deployed, how does a server, a web or an application server, fold itself into a load balancing rotation? How is the process of its launching and the logging of data from that server automated? How does load balancing occur? These are all fairly sophisticated requirements that only happen after the automatic launch, and we'll take you through that. And then finally, you need an environment where you can monitor what's going on, you can see and control what's going on with the automated scaling, as well as an audit trail, a full life cycle tracking system that can tell you when your site has scaled up and then down again, what happened, when, for what reason, and be able to go back, for example, and look at server number 27 last Thursday and find out why it launched, whether or not there was a problem, and have a way of tracking the log and success and error files of what might have happened on that server long after it's been decommissioned. So with that, let's get ready to launch in. We're going to show you a configuration now. David's going to walk you through in the RightScale interface configuration based on the model that you see here, which includes load balancer front ends, application servers that are automatically launched to absorb additional load, backed up with a MySQL master-slave configuration. So David, walk us through.
So we're going to start with this deployment, this standard 4-server setup. It has 2 front-end servers and a master-slave database. And down below here, you can see that we have no auto-scaling arrays set for this deployment. So I'm going to step you through the process on how to create an auto-scaling array.
David, let me interrupt for just a quick second. Let's define what an array is for people. Go ahead.
An array is it's just an array of servers that can be provisioned or deprovisioned, and they're based off the same standard server template.
Right. So it's actually a collection, an elastic collection of servers from 0 through whatever number you want.
Exactly.
And it's all the same type of server. And so we call that collection, which is elastic, an array.
So I'm going to start by creating an array, and we'll start on the arrays page under the manage in the left-hand navigation. Now I want to have this array be deployed in the EC2 US cloud. So I'll click on New EC2 US, and in a moment it'll present me with a configuration page for my array. So next I'm going to give it a nickname. I'm going to call it App Array. And then I want to attach it to that deployment that I was just in. I'm going to make sure it's active after I create it. Next, moving on, we're going to set the server options. And as Michael said, each server that's launched within the array is configured the exact same way based off a server template. And a server's template starts with a write image, which is simply a base machine image, or AMI, that normally contains the operating system, and then adds write scripts that define the role and behavior of that particular server.
So is this a way to really get predictability in exactly what the server is going to do when it launches?
Exactly. If you noticed in the previous demo, when these spike up and reduce load, that server template had intelligence to register with the load balancer so it could redistribute the traffic.
Great.
So I'm going to go ahead and make this a Rails application server. And then I'll provide it with standard, an SSH key and a security group. And a security group is an ingress firewall for your server. Next, we're going to talk about the server allocation policy and how much you want to scale or limit the scaling. So for this, I'm going to start with just 0 in the array because I have the 2 front-end servers in the deployment, and then I can leave it at 20. Lastly, we're going to set the alert threshold. So when you have, say, 4 servers in an array, before an action can take place, it needs to surpass the decision threshold. So in this case, it would have to be 3 of the 4 servers voting to either grow or shrink the array. And you can resize by 1 or multiple servers. And you can also set the calm time, which is the amount of time before it takes another action. So I think
now why do we set a calm time?
You set a calm time because if there's no calm time, then you can take multiple actions one after the other before another server actually became operational, because it takes anywhere from 3 to 6 minutes for a server to boot up.
Ah, okay.
So I'm going to go ahead and save that. And if we go back, we can see that the array is now attached to the deployment. So next, in order to get the auto-scaling working, we need to set alerts and escalations. So let's go ahead and create escalations to grow or shrink the array. And escalations is an action or many actions strung together. So I'm going to go ahead and click New, and then I'm going to provide it with a name. And this escalation will be vote to grow the array. So I'm going to click Save, and then I'm going to have to supply it with an action. So let's go ahead and do that. So any action we can take is send an email, reboot the server, relaunch a server, or even run a script across the server. But in this case, we want to auto-scale that array. So I'm going to go ahead and click Add. And then I'm going to need to tell it which array to auto-scale. So as you recall, I called my array app array. So then I'm going to click Save. So now for the purpose of this demo, I'm going to jump ahead and configure the alert specifications. But normally you'd have to also create an escalation to shrink the array. So
right. One quick question before you go on. When you're voting to grow the array, why doesn't that server just launch a new server? Why does it vote?
That's because of that decision threshold. So you can specify a certain threshold for when an action takes place. So we want the majority of the servers to either vote to grow or shrink an array before that action is taken.
Okay, so if you had one server that for some reason got really busy, it wouldn't necessarily cause a rogue auto-scaling event to occur.
Exactly. It's the collection of all the servers in a voting pool.
Let's ask one other question. The decision threshold, that 51% that you had, that's who's making the decision at that threshold?
Yeah, so it's the collection of all the servers. And so in that case, we need 51% of those servers to either grow or shrink the array before we take any action.
Okay, so that's the percentage of servers that are voting that have to vote a certain way for something to happen.
Exactly. That's why if one server is busy, it doesn't just take an action.
Great.
Okay. So now let's go ahead and jump to adding the alerts to a server template. In this case, the server template that was based off in the array. So here I'm under the Alerts tab, and then I'm going to have to create a new specification. So in this case, I want to, the CPU is busy, so we're going to want to escalate to grow the array. And then I'm going to define the metric that I want to use. In this case, it will be the CPU idle value.
Those metrics all different monitoring aspects of the server that are monitored?
Exactly. Those come pre-built into the server itself. So next, we want to set a threshold to know when we want to vote to grow or shrink the array. In this case, we'll set it at 40%. So if the CPU idle value is less than 40% for a duration of 3 minutes, then we want to go ahead and take an escalation to vote to grow. And I'm going to use the escalations that I created prior to this demo, so I can go ahead and add it.
So you're actually creating a policy or a rule there governing the auto-scaling.
Exactly. So if you go down here, we have the CPU busy. Now, like the policy in this case is the CPU idle value is less than 40% for 3 minutes. Then let's go ahead and take that and vote to grow the array. Now, also I'd have to add on the alert to shrink the array. But I'm going to go ahead and add that to one of our front-end servers so I can show you how that's done. So in this case, since we've already, actually I'll have to create I'm going to actually go ahead and copy that previous alert so I can add it to my front end. So we're going to go to the private server template, And then we're going to select the Rails application server. There we go. Click Next. Oops. Now I want to find that CPU busy. Now that I've selected that, I can go ahead and click Add. So as you can see, I didn't have to recreate that, that specification. I can just copy it from a previous server template.
Oh, wow. So you're actually able to reuse alerts from one server template in another.
Exactly. And so you're going to repeat this process for when your CPU is idle as well, so it knows when to shrink the array.
Good. I have a quick question that came in over the line. Could you define what custom metrics are in monitoring? And
sure. Oh, that's a great question. We had one of our customers who wanted to, they wanted to scale based off the amount of VoIP calls they were receiving rather than the CPU time. So what they did is they were able to create a custom plugin that we can monitor, and they were able to trigger the auto-scaling events based off the number of VoIP calls that were being processed on a particular server. Now that we've covered how to create the array, let's go ahead and take a look at the finished product. I'm going to go ahead and click on the dashboard. And then we can see that full deployment up and running. And you saw the, the monitoring graph for when the servers were scaling. But let's go ahead and take a look at that array that's live right now. And we can see how many servers are in the voting pool. So as you can see here, we just have the two front ends that are currently up and running. But as servers, as we provision new servers, they will be added to this voting pool in order to, decide when to take the next action.
well, that's great. I can't help but I look at that decision threshold and think, what a great idea that if only it were implemented in some of the elections that have been happening worldwide recently. Okay, good. So thanks a lot for that. And one quick question before we go on is, as powerful as all that is, it looks like it might be a little confusing, maybe for a newcomer. So if somebody is just getting started with RightScale as a customer, how do they get oriented within all those menu items and settings?
Sure, that's a great question. So you're going to want to start with the server template. That's one of our building blocks. So when you auto-scale new servers, it has the intelligence to add itself to the existing cluster. So I would go ahead and play around with the server templates, and then you can move on to creating arrays based off certain server templates.
Right. And there is actually a formal onboarding process that our services department will take people through to help them set all that up.
Exactly. And so part of the onboarding process, they'll scope out what events that you want to you want automated. And another example of that is one of our customers is able to work 6 hours a week, three times a week for 6 hours. And he's managing 300 servers, but through correct policies that he created with alerts, he was able to automate his day-to-day activities.
Great. So that comes back to the third box that you saw of expertise and service, that RightScale is there to help you use all this power to configure it to your specific needs. So, we showed you that basic configuration of a scalable website with the app service scaling out. Also just wanted to share a diagram. Earlier on we mentioned a couple of the media sites that do intensive media rendering or transcoding. Animoto is one example of that, and this is the kind of architecture they're using. They have the same scalable website in the front, but then they have what we call RightGrid, our grid edition, running in alongside, which is the yellow box at the bottom, which is basically a batch processing system that scales not just according to a load from web traffic, but instead it scales based on jobs in a queue. So it's a batch grid processing framework that handles variable number of jobs coming in over time. And in fact, that was the portion of the system that was driving so much of the scalability when Animoto went from 50 to 3,500 servers. It was all about the rendering time of creating those movies. And they were all processed through this input queue, driving a scalable number of worker servers, which then produced output. In Animoto's case, that would be input queue jobs specifying the digital still photos being processed into movies that show up in the output queue and then are handed back to the main website for viewers to view. So just a quick summary before we wrap up the presentation portion and open it up for questions. What we've showed here in terms of benefits is that You get to take advantage of predefined frameworks that have been tested, built according to best practices. You have complete configurability in the rules and policies governing the automation around scaling. You get to leverage this kind of automation throughout the deployment lifecycle, which allows you both to create additional copies of your deployments for testing and development and staging, and it also lets you track the operation of a production system through many generations and through different scalability runs. And finally, all of this is offered up in a transparent form that's also portable across different cloud infrastructures, which really helps preserve freedom of choice for you as a customer as to which cloud you'd like to run on. There may be different reasons why you prefer one or another that might involve pricing or geographical location or security and regulatory compliance or other reasons. So really helps you avoid lock-in.
Okay, that's the end of our formal presentation and demonstration. We're going to open it up now for live Q&A, and we've got some interesting questions here. Why don't we start with this, because it has to do with auto-scaling. What type of application changes would need to be made to take advantage of the auto-scaling?
The beauty about that is you don't need to make any really changes to your applications. You just need to set those alerts on the server itself that's hosting your application. And you let RightScale monitor that server and take actions on your behalf.
So the answer is very few, if any.
Very few, yeah. So what other cloud computing companies do you work with besides Amazon?
So I'll take that one. We support GoGrid and Flexascale. We have support coming soon for Rackspace's cloud through their acquisition of SliceHost as soon as their cloud server technology is fully released. We're working with the Sun Cloud and actually many others that are in development. And in April, we also announced a technology preview of RightScale managing private clouds that are built upon and powered by the Eucalyptus system. Eucalyptus is an open source project. You can find it at eucalyptus.com, spelled like the tree that comes from Australia. And you can download Eucalyptus. Basically what it is, you put that set of software on your own servers, and it creates an EC2 compatible auto provisioning system that can then be registered with RightScale and managed that way. So that's a list of clouds. That list is changing all the time, Betsy, because there are a lot more infrastructure providers getting into the cloud infrastructure market.
Yeah, Michael, we've got somebody interested in private clouds. It looks like they want to use them to manage their ERP app servers. So maybe we ought to talk just a little bit about private clouds and hybrid clouds and the advantages of private versus public.
So yes, so when dealing with the public cloud, you have to, some people worry about security and whatnot, and that what really drives people to use private clouds. So you're really in control of your data. In terms of hybrid, we have a lot of customers who have expressed interest in being able to burst out into a public cloud from their own data center. And we've seen people do that, for example, with the Grid Edition, by being able to fork which job goes where, either in their own internal data center or out into the public cloud.
And I would just make one addition to that is that security in the public clouds is actually extremely good. Most of us have our credit cards with Amazon. I know I do, and have a high level of trust there. Their data centers are extremely secure, and they've worked hard on security at all levels, as other cloud vendors also. But I think the aspect that may drive more private cloud usage is if there are regulatory compliance requirements that just are difficult to meet because of the paperwork that would have to be involved in getting Amazon to sign on or validate, that you don't have to do with your own data center. And also when you already own some substantial amount of data center infrastructure yourself, it's already been invested in, it's already been paid for, and so at that point there's a desire to use it in a more effective cloud architecture. So those are all reasons. Again, we'd recommend check out the Eucalyptus download that can register with RightScale. And I think we have our information there for the sales department. All of our salespeople are really account managers who are pretty knowledgeable consulting about different use cases and what's appropriate to deploy private or public today.
Good. Okay, we've got a question here. What is the real difference between using RightScale or just running Amazon Web Services without RightScale?
So the real difference comes in three forms. One is that RightScale, having been born over 2.5 years ago, has been working for a long, long time on cloud management and has very sophisticated capabilities across how to automate servers. So automation is one key advantage, as well as the architecture that we utilize. I think you heard David refer to server templates and deployments. These are architectural constructs that exist only in RightScale that really allow you to automate at a different level, because these constructs allow you to dynamically configure servers, or allow them to dynamically configure themselves really on a system-wide basis at boot time. It means that you have a flexible, agile system as opposed to a system where you're dealing with machine images where all of the behavior is hard-coded into a single disk file. In addition, we have a very strong services department that helps with the onboarding process as well as ongoing support, which is another big benefit. If you roll that all together, I think most companies find that their savings from using RightScale vastly outweigh what the cost of RightScale is. The savings both through automation of systems that then perform well and help you avoid downtime and customer frustration, as well as the savings that let whatever staff you have focus more on more important core competencies besides the nuts and bolts of running deployments just on a production basis.
Great, and we've got somebody who wants us to drill down a little further than that and look at the differences between auto-scaling from RightScale versus the auto-scaling that AWS is offering.
Sure. So, Amazon has been great about bringing powerful new features out. They tend to bring those out at a very low REST interface web services level, and that's what they've done with the auto-scaling capability also. If you have programmers who want to go build an automated system using those low-level interfaces, that's a possibility. RightScale really offers a fully integrated system that's turnkey, that's ready to go, which offers a lot more automation in an integrated way. And then on top of that, you still have the problem with Amazon's auto-scaling. It really focuses on the automatic launching of servers. And if you remember back to our earlier diagram, most of auto-scaling, most of the complexity that's required there doesn't have to do with just simply launching a server. It has to do with how that server behaves after it's launched, how it configures itself, how it folds itself into larger collections of servers in a load balancing array, etc. So in those aspects, RightScale really has the advantage in terms of a fully automated auto-scaling system.
Yeah, and Michael, we're getting a couple other questions around Amazon. Are we going to support the load balancing and monitoring from Amazon?
So I believe those are on the roadmap for us to support. I don't have a precise date for you, but as we've done quite religiously all the way along, we're very committed to supporting the low-level features that Amazon brings out and incorporating them into the RightScale integrated system.
Yeah, and I think we're also committed to flexibility for our customers. So some customers might want to use the AWS auto-scaling, and some people might want to use HAProxy. So we'll offer a variety of different options.
To go back, there's another question here. Aren't there server templates found in Amazon too with the different AMIs? That's a great question. AMIs store all the image information statically on the AMI itself. So in order to say when you were auto-scaling, What we do is at runtime, we'll dynamically, grab your application from your repository and install it on the machine. So if you have any changes, you get the most up-to-date changes automatically, as opposed to when you're using the AMI model directly. You're going to have to make your change on your image and then go ahead and rebundle that image, which can be a time-consuming process.
Yeah, I think so. We've got some more kind of what do we support questions. So it looks like we've got operating system level support. So do we want to talk about what operating systems we support?
Sure. The question is, do you support Ubuntu with server templates? The answer is yes. Ubuntu as well as CentOS, is that right?
CentOS.
Yeah. Those are on the Linux side. Do we support Windows? Yes, we have support for Windows. It's not as advanced yet as the support for the Linux derivatives, but it's catching up quickly, and we have many customers using Windows servers as part of RightScale implementations.
Yeah. We've also got some questions about do we support other kinds of software vendors. One question is do we support application level monitoring? And so maybe we want to just talk about our partnering strategy and our ecosystem.
Sure. We have many partners coming on that are going to focus on application monitoring. One of which is already in the dashboard, which is New Relic, and they provide a monitoring, application for your Rails website, your Rails application.
Right, focused on Ruby on Rails application monitoring and optimization. It's a fantastic package if you're working in Rails. More generally, we do support really any kind of application level monitoring through that custom plugin interface. You'll notice if you test out RightScale's monitoring that there are some metrics captured for things like number of queries hitting the database, number you saw on the screen, the number of Apache requests coming in. Those are some examples of application monitoring that come bundled with the system. But really, it's also possible to create a plugin to monitor almost any kind of application metric that you could write a plugin for.
Okay. This is really a service question for us, or professional services. How is RightScale involved in designing or configuring applications to be ready to run in a scalable environment?
So I'll let you chime in a second, David, but really that's one of the core things that we do. Our services department, in fact, even the account managers that you first engage with, as well as David, deal with customers who have design questions all the way through to implementation questions. And it's a key role that we play as a partner all the way from, as I said, from when you're architecting your application, what you need to take into account, all the way through to implementing.
Exactly. And that's part, and RightScale is an on-ramp to the cloud. So when you come and engage with our services department, the first call would be a scope out call, and you would detail what you want to achieve in the cloud, either be scalability, fault tolerance, whatever it is. We will provide this streamlined process of so you can meet your deadlines in order to deploy in the cloud.
Okay, here's another question. Can the cloud be used as a disaster recovery solution for a data center?
It most certainly can. You would have to architect your application either in multiple clouds, or in the case of Amazon, they provide multiple availability zones. So you can have your deployment in multiple availability zones. Just in case one goes down, you don't have a single point of failure. It'll trigger over into the other availability zone.
Right, and if you're running an application inside an internal data center, you can also use cloud computing resources to create a disaster recovery version or alternative for that application, which by definition places it in another fault-tolerant zone so that you get much more resilient, reliable capability there. And one of the advantages of the cloud is that you can in fact run a kind of a minimal configuration or be ready to run a configuration that can then scale up in the event of an outage or a disaster where you need to suddenly switch to the cloud, but only pay for the minimalist configuration when such an event has not occurred, which we all hope is the vast majority of the time.
Yeah. Now we're getting some questions about database scaling and the types of databases we support.
Yeah, I'll read the question. David, if you want to take a shot. Do we support auto-scaling for MySQL, or should I use Amazon's SimpleDB?
We've had customers in the past scale out their slaves for reads, but that requires some modification with DNS. But we do have ISV partners coming in the pipeline that address this problem specifically, scaling out your databases and whatnot. And we do provide server templates for MySQL, so there's no need to set that up. You can use that server template right out of the box and get up and running.
Yeah, I would just add, please contact us, because those solutions are going to be available very shortly for scaling MySQL in several different ways from different ISV partners. In addition, just a quick comment on Amazon SimpleDB. That is a very powerful scalable data store, but would like everyone to be aware of some of the key characteristics. One of them is it is not a relational database. So if you have some existing application or people who want to treat the data store in that way, I would really steer you to look very carefully at it, and because it might not meet your needs in that way. And secondly, it has characteristics from a multi-use point of view, things like eventual consistency. If you have more than one other client server accessing the database and you need transactional consistency, again, you won't find it in SimpleDB. So it's really a question of, does your application for data match what that data store provides? And that's another area that we can help consult on in the early going.
Great. Okay. Do we know enough about Akamai's style of web hosting to be able to comment on this? How different is what we're doing from that?
Sure. Akamai, really their main focus is on content distribution, or they're a CDN. They're probably the biggest and most famous CDN. So they're very strong at taking digital assets, be they images or movies or any kind of a file, distributing it around to local access points so that the access speed is very fast. So as a bottom line benefit, what they're good at is making websites fast from wherever you're accessing them, really around the globe, because they have so many points of presence. We have customers using Akamai as part of their solution with RightScale. They also use other content distribution networks. Amazon itself has one called CloudFront. There are other competitors, Limelight, etc. So Akamai, I believe, is moving more into the web hosting business, but that's really what their strong point is as a CDN, and it's completely compatible with what we do in other clouds and RightScale.
Okay, we're getting a few questions around pricing. How does the pricing model work?
Yep.
You might as well go through that.
So go ahead.
Sure. We have various plans, one of which is starting at $500 a month, and it works all the way up to RightGrid, which is also $500 a month, and then up to Premium, which is the combination of the two, which is, I believe, $1,000 a month. Is that correct?
Right, up to an enterprise edition. All these are listed on our website. You should think of RightScale pricing as having two components. One is the monthly subscription, which includes a bucket of hours, of server hours that can be managed. And so the $500 covers the first 15,000 of server hours managed, which is roughly equivalent to 20 servers running full-time for a month. Of course, you could also run 1,000 servers for 15 hours because in the cloud it's utility-based. So it's really utility pricing, and then there's an excess fee of 3.3 cents per hour for any hours over whatever the bucket of hours is with that floor. There's also a setup fee that starts at $2,500 that covers this onboarding engagement that we've described earlier, just providing everything you need to help you get migrated over to the cloud and get up and running successfully.
If I can add to that, with the Premium edition, you also get $250 worth of credit, and so that can be applied to our sysadmin package, which we monitor your servers for you, and so that $250 can be addressed or allocated to that or to consulting hours on a monthly basis.
Right, and you get more better support with the Premium package, don't you?
Exactly.
Yeah.
Exactly. Okay, I'm going to use the last question to wrap us up here. It is in the trial version of RightScale. Do I have to sign up for AWS first? We have two versions of trials. We have a trial that you can do, that you can use if you have credentials on AWS, and we have a trial that lets you use our credentials for up to 10 CPU hours. So both of those are available through our website at rightscale.com/free trial. And in fact, if you go to the website, it's hard to miss the free trial buttons. If you're interested and excited about what we've talked about today and would like to talk to one of our representatives about what your application entails in terms of getting it to the cloud and scaling on the cloud, you can reach us at sales@rightscale.com or over the phone at 866-720-0208. And this webinar, like all our other webinars, will be recorded or has been recorded and will be on our website in the next 24 hours. So go to our website in the Information Center, go under webinars, and you'll see this one as well as a host of other webinars that really include a lot of best practices that we've done over the last 9 months.
Yeah, we have a lot of information on the website. There's also pointers to our blog, to our wiki. There's a wealth of information about how to deploy in the cloud that goes well beyond scalable websites. We'd invite you to visit. I just wanted to add, Betsy, that our two answer demons who are on the chat lines will stay on for a while after we conclude. If you have ongoing questions, they'll stay online to help answer those.
Exactly. So we thank you for spending an hour with us, and we hope it's been valuable and that you will continue to participate with us on these webinars.
Thanks very much, everybody.